Okay, now we're going to look at problem 8. You're asked to compute the GCD using Euclidean algorithm for 240 and 55, compute the LCM, and then also 17 raised to 101 mod 11. So I'm going to use this here. Okay, so GCD of 240 and 55. Using the Euclidean algorithm, we need to see what is 240 divided by 55, what is the remainder? So you can use a calculator or any other methods, but basically 240 goes into 55 goes into 240 4 times, and that's 220, and so the remainder is 20. So what that means is that this is GCD 55 20. And then we look at what is 55 mod 20. 20 goes into 50 twice, and the remainder is 15. And then we do 15, and then 20 mod 5. 20 mod 15 is 5. And then finally, GCD of 5, and then 15 divided by 5, the remainder is 0, and the answer is 5. So that's the final answer here. Part B asks, what is the LCM? And LCM is just the product of the two numbers divided by the GCD, which we know from the previous, it's 5. So you can leave it at that. I said in the problem statement, if you don't have a calculator, leaving it that, it will give you full marks. But if you want, this is 240 times 11. And if you want to work it out, it's basically 2640. Okay. And then the last one, where I'm going to erase this. The last one is, what is 17 raised to 101 mod? Let me just quickly check mod what? Mod 11. So here we have to use Fermat's little theorem. Fermat's little theorem says that any number a that's not divisible by prime p raised to the power p minus 1 is congruent to 1 mod p, and p has to be prime. In this case, 11 is prime, so what that means is that any number a raised to the power 10 is congruent to 1 mod 11. Now, 17 raised to 101, it actually doesn't matter that 17. The point is that this is 17 raised to 10 times 10 plus 1, which if you use normal exponent rule, can come down to this. But we already know that 7 raised to the power 10 is just 1. So the 1 to the 10 actually just disappears, and then you're left with 17 mod 11 and 17 mod 11. It's 6. Okay,